Welcome to the Develop Yourself podcast, where we teach you everything you need to land your first job as a software developer by developing yourself, developing your skills, your habits, your networks, and more. My name is Aaron Hayslip. I'm one of your hosts, and today we're diving into Git and Github. This is an intro podcast. We haven't done one of these in a long time. A long time ago, we did an episode called Intro to JavaScript, which is really popular. It's basically an auditory way to learn the fundamentals and background of a topic, and this topic in particular is Git, GitHub, version control. If you're new to programming, new to coding, this is a great episode for you to learn the context around Git and GitHub and my personal recommended workflow for using those things. Okay, so let's begin to talk about Git, what it is, how it's useful, my recommended flow for using it. So if you've never used it before, this episode is a good episode for you. If you've been using it for a while, maybe you were new, you just started a boot camp, you're thinking about a boot camp, you're learning on Code Academy or some other online course. I think a lot of times what happens is I see students jump right into using Git and GitHub and not really understanding the context of, why are they using it? What is it for? Mostly because it's not super useful until you're using it with other people or contributing to open source code or working on a project in a team. And so it's kind of can be confusing to understand, what is Git and why would you use it? So let me back up real quick and first give you some context for what this is. Ultimately, it's version control, which that's kind of a loaded word. What does version control mean? Essentially, whenever you're working on some code, you want to save the work as you're going, and then you want to be able to back the work up just in case, you break something, you want to go back to a previous commit where the code was in a working position, or you want to collaborate so you can work on the code and someone else can at the same time without overriding each other's code. This is the basic reason why we use version control. And I won't go into the history of version control or what it is, but there's been a lot of other protocols for using version control that came before Git, but obviously Git and GitHub are the most popular ways to use version control these days. Now, let me also note that Git and GitHub are completely different. Git is the actual software that we use to keep track of our code it's the actual version control software, whereas GitHub is a completely separate entity, website, organization. It was bought not too long ago by Microsoft, but it's a website where people actually push their Git repositories, and I'll explain what a repository here is in a minute. So just for off the bat, it's a separation to think about. Okay, so my hope is that you could be in the car right now and you could be learning something about programming without actually having to sit at the computer and watch a video. I think it's hard for most of us to watch a tutorial. I don't know how many Udemy courses I own that I've never completed. So that's what this is. So let's first get ready, no pun intended, to start using Git. The first thing you'll do is actually go to the Git website. I'm not going to explain this right now, but you would download Git onto your computer. You could go to GitHub, set up an account, all of that. I'm not going to explain the account creation. I'm just going to give you a audio reference to how this would work. This isn't going to be something you can reproduce as you're listening to this, so that whenever you go down to set the computer and go through whatever your tutorial is, or you watch your YouTube video, you'll have a lot of context for how to use this. The first thing we want to do is, if you're working alone on a Git project, this is going to be the flow. This is how you would do it. The first thing I would do is I would open up a new terminal. If you're on a Mac, it's just called Terminal. You can download some cool other kinds of terminals to use. iTerm is a popular one. And I would start off by creating a new empty folder. Now, normally I keep all of my code in a folder literally just called code inside of the home folder of my Mac computer. And so I would just create a folder called code, and it's where all the code goes that I ever create, whether it's for a job or something else. I just keep all my code in one big folder called code. That way I know that everything that's inside this folder is some kind of coding project. The next thing I would do once I'm inside of code, and you can obviously get in there by typing in cd code, which, by the way, the way I use Git, I've actually never used a UI. So if you're not familiar with the terminal, I'm going to kind of give you, I guess, a quick overview of that on the side as we go. So the terminal basically is it's that little program that if you're on a Mac, and again, I'm going to be showing you from a Mac here. If you go Command Space Bar and type in terminal, it'll come up. It's called terminal.app. Then if you open that, you'll see it's usually white by default. You'll see like a little white text area, and it will give you the name of your computer. And it'll just have like an empty cursor, and you can type in commands. And basically what you can do from your terminal is you can navigate the folder structure of your computer. So what I would do at this point is to see what all my folders are, I would type in ls. That's going to list all of your folders and where you're at. Then what I would do is I would cd space code. So that's going to switch me into my code folder. If you hit ls again, you'll see all of the different folders inside of your code folder. Then from here, I would create a new folder for whatever project I'm working on. So let's just call it mkdir, which means make directory. So that makes a folder, mkdir space. Then I would type in, whatever test project. That's going to be the name of my folder. So I would hit that, and I could do ls, and I could see now that test project, that folder has been created, but I'm not inside of it yet. So I would do cd for change directory, and then typed in test project and hit enter. Now I am inside of test project. Now if you do ls, you'll see that there's nothing that comes up because your folder is empty. So if you want to go ahead and create something, you could do, create an HTML file. I'm going to do that by typing in touch, which creates a new file, space index.html. Now, if you're not familiar with any of these commands, don't worry. You don't really actually need many more than the commands I'm showing you or telling you about for now. You could take a quick intro to terminal course on like Code Academy or something like that, and it would give you all this information. So if I type in touch space index, I cannot talk, touch space index.html, and hit enter, and then do ls again, I can now see that I have an index.html file. Now, for most of you, hopefully you've got your environment set up already. I'm going to assume that you've got something like VS Code installed. And one of the things you can do with VS Code is install a command that's going to allow you to open up the folder that you're currently in inside of VS Code, so you don't ever have to leave the keyboard. And to do that, I'm going to type in just the word code space dot, and that's going to open up everything that's inside of this current folder, which right now it's just, index.html. And it opens up, and it's going to then allow me to edit that index.html file. Now, you're welcome to put any kind of scratch you want in there. Again, you're not doing this, you're listening probably. So just trust me that I'm opening up index.html. I'm going to do an H1, which is obviously a heading, and I'm going to type in hello world, right? So that's the code I have initially. I literally have a project that's empty, has one HTML file with an H1 that says hello world. At this point, let's finally get, I can't keep saying Git. Let's get to Git. So if I go back to that folder, I'm inside test project, and I want Git to now know about this project. What I'm going to do at this point is type in Git, G-I-T, space init, I-N-I-T. And it's going to say initialized empty Git repository in, and in my case, my folder path is users/AaronHayslip/code/test project. And then you see /.git. Now, if I do ls here, nothing's changed because Git has inserted a dot folder, and dot files and folders are hidden by default. So if I do ls space dash LA inside my terminal, I hit enter, I can now see the hidden items, which there are a few, and one of them is .git. Now, this may not be correct, but the way I think about it is now we've kind of inserted a tracking bug inside of our folder, and now Git has been injected, and it will now track all of our activities. Kind of like, I don't know, I'm thinking of a movie here, not The Matrix, but something where you like inject something into the person's neck, and now we're tracking their every move. We've done that now with Git. And so now I can type in git status. So git, that's G-I-T, space status. I'm inside of, again, the test project folder. And it's going to tell me the status of all of my files at this point. What does that mean exactly? Well, I'm going to explain that. But one thing that it says on branch master, no commits yet. Then it says untracked files, and it has index.html. Let's talk about what all of this stuff means. And again, this is us diving into Git finally. So on branch master, let me explain what that means first of all. So Git has what's known as branches, and branches are the feature which allows you to work on some code at the same time as somebody else without you changing each other's code, right? And so let me try to give you an example of this. So let's say that I'm working on a painting, and my painting is a painting of a man with a top hat and a black jacket, right? He has no facial hair, just a top hat and a black jacket. Let's say that I am a specially trained artist who is able to, draw beards, for example. And then my friend Tom, let's name him, is a specially trained artist who has the ability to draw glasses very well. I'm gonna say, hey Tom, let's collaborate on this. I'm gonna do the beard, you do the glasses. He says, cool. So I'm gonna check out a branch. Check out means I'm going to go get that branch. I'm gonna create a new branch called add beard. Tom's going to create a new beard called add glasses. So now as we're doing this, we both have our own copies of the original branch, which is normally called main or master. That's the original one. And we have our own copies of it. So as I edit it, and maybe even break some stuff, make some mistakes, whatever, it's not affecting the master branch. And by the way, and we'll explain this here in a minute when I talk about collaboration, we always assume that the master branch is live and in production. It's what our millions of users are seeing. If we have a product that has millions of users, it's what they're seeing. So we don't want to actually ever directly edit the master branch. Instead, we want to make changes on our own branches and then merge them later. And we'll talk about merging here in a little bit. So that's what branches are. So we'll get into those here in a moment. But in the beginning, your branch is the master branch because that's the only branch that exists. All right, that's the first thing. Now, again, to recap where we're at, I typed in the command git space status, and it showed me three things. The first thing it showed me was on branch master. So I wanted to explain what that was. The second thing it shows me is no commits yet. So therefore, I wanted to take this opportunity to explain what commits are. I think of commits like snapshots, like photographs that you're going to take to track the progress that you're making. So let's say, this is an example that I just thought of the top of my head, but I've recently bought a used Toyota Tacoma, and I have learned that there's quite a cult following of usually young men who buy Tacomas and then, soup them up or upgrade them for off-roading. To be honest with you, I don't think many people actually off-road. We just all buy off-road vehicles to make us feel like we off-road. Anyways, that's besides the point. But I joined this community online called tacomaworld.com, and it's hilarious. But what I find are people posting pictures of the truck when they first bought it, and then as they continue to make modifications on the truck, they post pictures. So the first thing they might do is remove all the chrome decals and add black ones. They might change the grille. They might then change the suspension, then the wheels and tires, and then add a new bumper, and then these cool lights. And so what you see is, in the beginning, a very vanilla-looking, small, kind of weak truck. If we're honest, it's not a big truck. But then at the end, you see this like monster off-road machine, and along the way, they take snapshots of the work and of the progress. And that's the same with Git. As you write your code, we want to commit often. And what a commit is you literally making a note and taking a picture of the current state of the code that you're writing. And that way, and the more snapshots you have, the more opportunities you have to go dive into those snapshots, look at what your changes were, and even revert some of them, come back to them, remove them. There's a lot of things you might want to do with your commits in the future. So we'll talk more about what a commit is here in a minute when we make our first commit. But what it's saying right now is hey, there are no commits yet. You have taken 0 snapshots. We're going to start tracking your changes, but right now we have not committed anything. We have no images of your code. All right, then finally, it's going to tell us that we have some untracked files. And specifically, it says index.html. It says, hey, we know that there's a file here called index.html. If you make any changes right now, like for example, remember we added one H1 that says hello world. If we had another H1 that says goodbye world or whatever, we make any changes, it's not going to track that change because it still doesn't know what's inside of that folder yet. But it gives us a hint here. It says use git add, and then it says, then you name the file to include what will be committed. And so let's do that now. Let's go ahead and get our first commit going. So what I'm going to do is I'm going to type in my terminal, git space add. And then I can either do git add space dot, which is going to add all of my changes, or Git allows me to specify which files you want to add to your changes. Now, right now we've only got one file, index.html, so adding everything or adding just that file will all be the same. So I'm going to do a git add space dot, just because it was less to type. Now, if I type once again git status, it's going to show me similar information, but a little bit different. It shows me 1, that we're on branch master still, thank you. 2, no commits yet, still the same. But then it tells me something different. It says changes to be committed, and it says new file index.html. And now normally, by the way, whenever it said that things that are being not tracked yet, it's told me that before, it showed it in red. Now it's showing new file index.html. It's showing it to me in green. And what we'd say at this point is what we've done with add, what's add is doing is it's telling Git what to track. And in this case, what we're saying is that this file is now staged. So these changes that we've made, they are been staged. They're ready for a commit. So now if I write a commit, what's going to be included? Well, the things that are included are the changes that we've currently made. Now, I'm not going to write a commit because I want to show you something real quick. Now, if I go in here and I say hello world and I make a change, I add an exclamation point, right? Now it says hello world instead of hello world. And I go back to my terminal and I type in git status. It's going to tell me a few things. It says all the same information that we're on branch master, no commits yet, changes to be committed, the new file. Then it says changes not staged for commit are index.html. And then now it says instead of new file, it says modified. So in other words, if I make a commit right now, what it's going to have is hello world without the exclamation point because I haven't told it to track anything other than that. So again, whenever you take a snapshot, when you actually do a commit, it's only going to take a snapshot of the changes that you've made. So what I'm going to do right now is I'm going to actually write a commit. And I'm going to type in git space commit space -m space. And then what that means is it's my message. What do we want to write about this commit? Now, commit messages could probably have its own podcast episode, but we just want to write what we did. And normally the first commit, I type something like init, like initialize, init HTML file, for example. That's what I'm going to write here. And then end quote and hit enter. And it's going to tell me some information. It says 1 file changed, 1 insertion. Now, if I come back to git status, it still has the fact that I've modified my index.html file, but I have not tracked that yet. Remember, I added the exclamation point. Now, if I type in another command here, git space diff, D-I-F-F, it's going to show me the difference between what I had before and what I have now that's not staged. And it shows me that I have an exclamation point that I need to track. So what I'm going to do now is if I were to, by the way, if I were to right now do another commit, it's going to tell me that there's no changes added to the commit, right? Because I haven't added yet that other modification I made. So what I'm going to do now is I'm going to add another commit. I'm going to say git add space dot git commit -m. I'm going to say add exclamation point exclamation, not explanation, exclamation. I can't spell it. Whatever. You can't see what I'm typing. Add exclamation point. And then it's going to once again say one file change, one insertion, one deletion. Now, by the way, the reason why it says insertion and deletion is because when Git tracks a change, it tracks it by line. It doesn't track it by character. So, for example, whenever I had h1 hello world without an exclamation point, and then whenever I added it, all I changed was I added one exclamation point. It doesn't think about adding a character. It thinks about I deleted the line that says hello world, and I added the line that said hello world and exclamation point. Okay, so now if I go back here to Git status again, it says on branch master, nothing to commit, working tree clean. If I go to Git diff, it will show me nothing. So we're good now. I've committed that latest change, and that's it. We're kind of off and rolling with our features. Now at this point, I want to go over how we could push this up to GitHub so that other people could see our code and we could even begin collaborating on it. But before I do, let's look at one more command. I'm going to type in git space log. And what log is going to do is going to give me a list of all the commits I made. Again, it's going to list off our snapshots. What I see here is I see my name, I see the date, I see when I added the new file, and I see the message. So it says init HTML file. And then I see my next one as well. It gives me the name, the date, and the time. And it says add exclamation point. So I can now see the log of all the commits I have been making up to this point. Okay, now that we've done that, let's get ready to push this up to GitHub. Again, I'm not going to go into the entire process of the account creation and all that. I'm just going to kind of give you a auditory, reference to how all of this works. But what you would do is you would go to your GitHub, you would go to your account, and you would create a new repository. Now, what is a repository? Repository sounds like a big fancy word to say, basically storage container. It's the way that we store something. So we want to create what we're calling a remote repository. So we've got our local repository, which is what we've been working on right now. Then we're also going to have a remote repository, which is going to be our code that exists remotely on GitHub. Now, why is it important to make a distinction between your local repository and your remote repository? Well, the answer is a little bit obvious. Whenever we're collaborating, right, and our code exists up on GitHub, let's say the master branch, for example, other people are able to get that code down, make changes, and push that code up. And then locally, we won't have those changes unless we pull them down. So we're going to go over those commands here right now. So the first command we need to know about is adding our remote. And so what we'll do is whenever you create your new repository on GitHub, it's going to give you a URL. And we need that URL because we need to know where to push our code whenever we're working locally. So what we're going to do is we're going to go back to our editor. We're going to type in the following. We're going to write git space remote space add space, and then you're going to name what this is called. Now, it's pretty common that if it's the main spot that you're going to be pushing to, if this is where the code's going to live, you're going to write in origin, right? It's going to be where it lives. And again, that's not anything other than convention. So git remote add origin, and then you're going to paste the URL, and you'll hit enter. Now, if you go back and you want to view this remote, you can type in git space remote space -v, and it will show you all of the remotes. Now, in the future, it might be helpful to have different remotes depending on if people have different forks of the code. We'll explain forking here in just a minute whenever we explain the pull process. Now that you've added the remote, if you want to push it up to master, the code that you've written, all you do is you write git space push, then you need to specify the remote. In this case, it's origin, and then you specify the branch, and it's going to be master. So again, git push origin master. Git push is the actual git command, and then where origin is the URL, and which branch master. And then you should see it all get pushed up. And if you go to your repository and refresh, you'll see the code that you've written now exists remotely. Okay, That being said, let's talk through how we would then collaborate on this code. And we're actually going to talk about it from a different perspective, not code that you've written and pushed, but code that someone else has written and pushed. Specifically, how would you contribute to an open source project? Now, in the beginning, this can be confusing because people talk all the time about open source code, and it sounds like, wow, that would be a cluster, right? If everybody is able to just to push any code they want anytime they want. And that's not exactly how it works. Open source code is freely available to be looked at and used, but usually whoever owns the code has the ability to merge things in. They're kind of like the moderator. So not everybody is allowed to push their code up, but everyone is allowed to make proposals at least for how the code should change. So this is how you would contribute to an open source project. Now, one example of an open source project is React. So if you actually go to github.com/Facebook/React, you will see the React code. It's all open source, nothing's hidden or secret. And then you can actually come in here and add to it or propose a change. So what you would do on GitHub is you'd go to the top and you see a little button called fork. And you would click it and it would ask you to sign in if you're not already signed in. And then it would ask you where you want to fork it to. And you would just click your profile, which is probably going to be the only option there. Now let's talk about what a fork is. Now I like to illustrate a fork by explaining a journey, right? Let's imagine, for example, that you and I are in Texas, which is where I'm at right now, and we're going to take a road trip together from Texas all the way to Florida, which is a terrible road trip, by the way. I've done it a couple times and I wouldn't recommend it, but we're going to do it, right? And so in the car, we're going to the same places, right? We got to stop to pee. We go to the same gas station, right? We need to stop for a burger. We go to Whataburger together. We travel through Texas. We get through Louisiana. And let's say that somewhere in Louisiana, we get into an argument. We have a fight, right? And we want to go our separate ways. And I say, I'm not going to Florida. It's too humid there. I'm going to go up to Chicago. And so my drive now is going to be, I'm going to go up through Mississippi, maybe Tennessee, clip Kentucky, drive through Illinois, get to Chicago. Whereas you're going to continue driving through Mississippi, Alabama, Georgia, and on down to Florida. And yes, I'm looking at a map because I wouldn't know how to say all this otherwise. What we've explained here is a fork. We've had a fork in our journey. Our journey was all the same. We had the same history from Austin, Texas, all the way to, let's say, New Orleans, Louisiana. From there, our journey shifted and we decided to go our separate ways. That's the same thing that happens whenever you fork code. Whenever at the point in which you made the fork. So for example, you forked the React code. What you've done is you've copied all of the code, that repository, from Facebook React profile and you put it on your own profile. But at this point, unless you ask for the updates, unless you pull them down, whenever Facebook updates that main master repository, you won't get those updates. And as you write code, the original Facebook React repository won't be updated. Just as whenever I'm driving up to Chicago, my friend, or if it's you, I forget what the example was, won't get those updates and vice versa. But all of our history up to that point was the same. That's what happens when a fork. And a fork allows you to work on the original code alone without having to, interact with the original changes and vice versa. So what you would do at this point is you would fork the code down by clicking fork, or not fork it down, I should say. You would fork it over to your own profile. And at this point, it only exists in your remote repository. Now what you want to do is clone it down to your local repository. So if you go to your own fork, which is, again, that Facebook React repository, but it's going to be on your profile, and you again see that green little drop-down button that says code, it's going to give you that same URL, and you'll copy that URL, just like you did whenever you added the remote locally. But this time, of course, this is code that exists remotely on your profile, right? But doesn't exist yet locally on your own code. So what we're going to do is you're going to go into terminal again. You're going to find a spot where you want to put it. So I'd put it in a place like code. And then you would type in git space clone space, and then you'd paste in that URL. And what it's going to do is it's going to basically pull down the code that exists remotely of your fork, and it's going to put it locally. And the reason why we call it clone is, unlike a fork, again, a fork is we have the same code up to a point, and then we fork off and we have two different histories, right? Again, this is the road trip example. Whereas a clone is the two histories should mimic one another, right? So you have your fork, but the clone that you have is a clone of your fork. So what exists locally for you should also exist remotely. So whenever you make any kind of changes and push them up, or what I should say, I guess, is that anytime you make changes locally, you should then push them up to your remote counterpart. And vice versa. If someone were to make some changes to your remote counterpart, you should pull them down so that your clone mimics it. Again, the clone is supposed to be a one-to-one match of what exists remotely. Okay, so that's a brief explanation of what the difference is between a fork and a clone. Now let's talk about how you would actually collaborate on a given piece of code, with branches. So here we're going to imagine that you're going to make some edits for the Facebook React. Let's say that you're going to add a new feature on Facebook, some upgrade to React to make it faster, more performant. And I don't know how you do this, to be honest, but let's just say that you're going to do that. So we would then, at this point, again, we've got our fork, right? And now we've got our clone. What we're going to do is check out a new branch because we're on the master branch. So we don't want to edit the master branch. We want to then edit a fork. So we're going to do the following. Inside of terminal, once we've got it cloned down, we're going to type in git space checkout space -b. That's going to be for branch space. Then we're going to name our branch. Now, usually you should name the branch based off of the feature. And normally we call these branches feature branches, which is the branch describes what the feature is. And I'm going to say that it's going to, the name of the branch is going to be React Performance. So I'm just going to do React -performance. And it's going to show you that you are now on branch React Performance. Now here you can make any kind of changes. Let's imagine that you change a bunch of code, you've added it, you've committed it, and then whenever you've pushed, instead of doing push origin master, you'll do git push origin, the name of the feature branch, which was in this case React Performance. Now again, origin is your own remote fork, right? And so you haven't actually talked to anybody at React yet or that repository. You've only made some changes there. Now what you can do is you can go to the main React GitHub profile. You can click pull requests and then click a button that says new pull request. And what it's going to do, it's going to allow you to compare changes across forks. So you'll compare from base main, which is like their master branch, and then you'll go to your branch. On the right side, you can do compare to a fork, which is your fork, and your branch. And then you'll click a button that says create pull request. And what that's going to do is basically create a dialog that's going to show what changes you've made, and then they can choose whether or not to merge those changes in or not. And that's a way that you would contribute to an open source project. Now, finally, to round out this intro to Git, let's talk through a scenario in which you and one other person, just to make it simple, are contributing together on an app, a feature. How would you actually use the different commands of Git to make that work? So let's imagine that one of you, for example, went through the entire process of creating a new repository, initializing it, pushing it up, and then actually on GitHub, what you can do is you can add collaborators, which allow the collaborators to have the same level of access that you have to the code, so they can actually push up to the repository as well without having to fork it. So let's say that you and another person have that. Let's say that it's you and Cindy. Let's just make up a name real quick. So you and Cindy are working on some code, and you both have the master branch. You're going to work on a feature, and they're going to work on a feature. So from the master branch, you're going to check out a new feature branch, which with its name, and they are going to check out a new branch as well. You're both going to work on the code. You're going to code whatever you want, add all your commits, And then whenever you're ready to merge it, you're going to do exactly what you just did just now with the forks in React, is you're going to create a pull request, which is going to show the code that you're proposing that gets pulled into master. Now, again, we always create a pull request because we never want to merge directly, which you can. There's a command called git merge, which allows you to merge multiple branches together locally. But we don't want to do that because the UI on GitHub will allow you to check for any conflicts. And we're not going to talk about conflicts in this episode. It's just outside of the scope. But that's how we would do that. And then once we merge that in, it's important that you are always pulling down. So what I mean is, if you, let's say that you wrote some code on your feature branch, you created a pull request, and you merged it into master. Master has now changed, but maybe Cindy doesn't have those changes yet because it's only changed remotely. She's going to have to, every once in a while, make sure that she does what's called a pull. So git pull, and then you actually specify the name of the remote and then the name of the branch. Kind of like, it's just the opposite of git push. And she's going to pull those down so that whenever she makes any changes, she has the latest of master in mind. And that is just a process that you continue going through. You would create a branch, make your changes, create a pull request, merge those in, then you would pull down the newest master, and then every time you want to add a new feature, you continue branching, pull request, merge, branching, pull request, merge. Now, at some point, you're going to run into a merge conflict, which I said is outside of the scope of this episode, but it's something that you will definitely encounter and will be not difficult to resolve. One last thing I want to leave you with when it comes to Git is don't be scared of it. You will probably mess it up like a lot, especially in the beginning, but there's nothing that you're going to do. I mean, for the most part, you won't break anything. So dive into those mistakes and those errors, because that's whenever you're going to learn a ton about this process. All right, that is it for this episode of the Develop Yourself podcast. Hopefully that gave you just a contextual guide for these different commands, on the personal front, init, add, commit, status, log, diff, push, pull, merge, what a fork is, what a clone is, what branches are. I mean, that is the main things you need to work on in the beginning. Down the road, you can work on squashes and rebase and, all kinds of other nifty things that Git can do, but hopefully this gave you a good introduction. If you want to learn more about becoming a software engineer, we have a program we run that is an intro to JavaScript. It's called Dev30. Check it out. It's dev30.xyz. We literally dive into all the things this podcast talks about: your habits, your network, your skills, your, what am I missing? Oh, mindset. We have a 30-day mindset podcast. So you listen to a short episode every day during Dev30. Then if you want to dive in even more and you actually want to become a software engineer, we've got an online code school called Parsity. You can visit us at parsity.io. That's parsity.io if you want to listen to me talk a ton and watch a ton of videos that me and my fellow instructors have created. That is the place to go. As always, thanks for listening, and we'll see you next week.